Hello friends, welcome to my channel. Let's have a look at a newly appeared problem. Problem 2449. Minimum number of operations to make arrays similar. In this video, we are going to demonstrate how to analyze such kind of problems. First, I'll read through the statement, and then we do the analysis, and finally we share the very straightforward code. First, let's look at the statement. So we are given two positive integer arrays called nums and target of the same length. So in one operations, we can choose two distinct indices. So this corresponds to two numbers. So we can borrow 2 from one number and add to the other another number. So this is what the operation actually does. So two arrays are considered to be similar if the frequency of each element is the same. So we are required to return the minimum number of operations required to make nums similar to target. So the test cases are generated such that nums can always be similar to target. So this definition of similarity of two arrays actually says that if the two arrays are similar, so in effect, so they contain the same elements counting the frequencies, but we do not care about the order, right? So that's the implementation of this definition. So here are three examples. We are going to go over their natures in the analysis part. So the constraints for this problem are the following. First, the two lists have the same length, and the length is bounded above by 10 to the power 5. So 10 to the power 5 defines the problem size upper bound. And also the third constraint or assumption is about the element range. So here let me mention that it's not negative. Actually it's positive, strictly positive. So it's possible to make nums similar to target. So this is a consistency assumption. So with that said, we are ready to do the analysis. Actually, the analysis is very routine in some sense. So here our treatment is the following. So we're going to separate even and odd numbers and do sort and do greedily matching. So here there are two observations that are important for this problem. First, if two arrays are similar in the sense of this problem, so they have the same sum. This is actually a very easy observation. Actually, so we can regard the two arrays are the same if they are similar. So, but we do not care about the element orders. So this is observation 1. So the second observation is that the operation in the problem statement does not change the odd even nature of a number. More specifically, if y is odd, right? So y plus 2 or minus 2 remains odd. So similarly, if y is even, so this evenness is retained if you increment or decrement by 2. So based on these two observations, actually there are the following implications. First, the observation 2 means that we could consider even and odd number separately in nums and target respectively. And the two observations together imply that we could do rough counting greedily and then divide by 2. So we'll specify the second this sentence below. So let's also analyze the three examples and let's guess what are their meanings. So if we look at example 1 and example 2, so they involve only even numbers, odd numbers respectively, right? If you examine, so in example 1, so odd numbers are even, and in example 2, odd numbers are odd. So example 3 actually covers the case that the number might have multiple appearances. In other words, it appears more than once. So combining all the three examples, so in other words, let nums be the concatenation of the three nums list in the three examples similarly for target. So this gives or yields a generic example, right? So that's the analysis for these three examples. So for our purpose to fix the idea, we just need to use example 1 to fix the main point, right? So here we can do sorting. So after we sort, so nums becomes 6, 8, 12, and the target becomes 2, 10, and 14. And then we can do greedily match. So we could start from matching from largest to smallest, or in the reverse direction. So let's match from largest to smallest. So if we look at 12 and 14, so we know we need to add 2 to 12 in order to match the 14. So which corresponds to one operation, because we have an add, right? And if we look at 8 and 10, we need to add 2 to 8 to make it equal to 10. So which corresponds to one operation as another plus, right? So if we look at 6 and 2, so we need to subtract 4 from 6, right? From 6. So in order to match the 2, so which corresponds to 2 operations. Here the 2 operation is minus. So in total there are 4 operations. So if we do not care about plus or minus, or we can see we counting all the plus or minus. So as we know, plus and minus are in 1-1 correspondence due to the operation nature. So the genuine operations needed is 4 interdivision by 2, right? So before we write the code, here is a comment. So the former 4 actually gives us a convenient way of counting without the need to consider or distinguish plus or minus. Overall, we just need to notice that the number of plus and the number of minus are equal. So this is another invariance in this problem. The first invariance is the odd and even, and the second invariance is the number of operations in plus and minus are equal, right? So with that done, so we can go to the coding. So here we are going to write with some redundancy to make the idea clear. So in other words, we can write very short code. However, that's not our purpose. So first, I'm going to split the nums and target into odd and even part. So odd nums. So I'm going to use list comprehension. So for y in nums, if y interdivision by 2 equals 1. So let's copy. We need to do sort. Let's see, sort it here. So this is the one. Let me copy this one, and then what we are going to do is get even part. So let's call it even. So we want to change this 1 to be 0. So let me copy again. So I'm going to change this odd nums to target, and change this to be even target. So but now we want to change this nums to be target, right? So here same target, right? So the odd nums contains the odd numbers in the original nums list. Then we do the sort. So similarly for other 3 lists, right? We do sort for all of them so that we can match. So this way, so here we need to change to be 0, right? So this is a preparation step. So let's call it preparation. So next, what we are going to do is to do the rough counting, right? And do rough counting and divide by 2. So for this, let me just write it into 2 parts. So odd operations, so correspond to, let's see, odd deltas. So this actually corresponds to, I'm going to sum. So we want to count ABS, so absolute difference of numbers in the odd nums and odd target, and then we're going to divide this by 2, right? So we want to see how many operations we need to make to match the numbers A and B in the corresponding position. So here for A, B in zip, odd nums and odd target. So this is the one. And similarly, odd and delta, or operations, I would say, maybe more precise. Let's copy this one. So for in odd, so in even, right? So here I'm going to change to even, this to be even. And then let's change this name, odd operations from odd, operations odd. So ops odd. So notice that in the current counting of odd operations or even operations, so we didn't distinguish plus or minus, right? So what we are going to return is nothing but ops odd from odd plus ops from even, and then divide by 2. So that's actually a translation of the above analysis. So now let's look at check. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the cases. I guess for this problems, for this kind of problems, so it's important to notice the invariant variables or quantities, and then that typically those quantities will help us write a short code or succinct code. So with that said, I guess that's it for this video. Thank you.